Alright, so this would be part 1 of the review video. This is the third period video. We'll start with 19 and we'll do every third one after that. Okay, so first go is always plug it in and hope that it works. Let's see, 25 minus 15 minus 10 over 25 minus 25. Yeah, as expected, that's 0 over 0. It doesn't equal 0 over 0, but it's that indeterminate form. So this one will factor and cancel, and then try it again. Right? So after you do your algebra trick, you try it again. And this time it should work. 7/10. And it looks like 20 and 21 are the same algebra trick. Right? Different problems, different factoring, but that same idea of factor, cancel, and then have another go at it. Oh, now I know why it feels like there's a ton of problems on this page. Because we're going to jump to number 31. Because there is no 22 through 30. So to further confuse myself on trying to do every third one. 31, if I plug in -2, I'm going to get 0 over 0. Obviously this one's on here to make sure we can factor with the sum of cubes. Same, opposite, always positive. So the x plus 2's will cancel. We try again with -2. So that would be 4 plus 4 plus 4 in the bottom, so 1/12. Okay, some limits with pictures. Remember these, the trick is just make sure you look at the right graph, right? Don't get confused on who's G and who's H. So the limit as x approaches -2 from the left on graph of H. H. -2 from the left is 2. Again, it's easy, but there's just a lot of things to keep up with, so just be careful. Minus, now we want graph of G. So looking at G, x approaches -2 from the left would be 6. And 2 minus 6 is -4. Again, I think the most missed part of these is people looking at the wrong graph because they just get going and try to go too quick. 37. 2 times h of x times g of x. Okay, so again, with making sure we look at the right graph. So as x approaches -3 on the graph of H. So graph of H, x approaches -3 is -3. Graph of G, as x approaches -3 is 3. And so 2 times 3 times 3 is -18. G of h of x. So here's where we got to be careful. So 2 into h first. So limit as x approaches 2 of h of x. That's the red one, or what I've labeled the red one. So as x approaches 2, we're headed to 0, but we're always a little more than 0. So like, you have to be careful. Again, that statement is correct. What I have written is correct. But I know that when I go to the next piece, limit as x approaches, it needs to be 0 from the right, or 0 plus because our answer to the first part is always a little more than 0. Okay, so now to graph of g, x approaches 0 from the right, and it turned out that it didn't really matter which way we approached it because we were going to hit 1 either way. Okay, 41, 42, 43. Oh, more algebra tricks. This one looks like it'll be the fraction clearing algebra trick. Remember, there's 3 algebra tricks. So if you get 0 over 0, then you can either factor reduce. We did some of those already. You can clean up fractions. That's what we're about to do. Or you can multiply by conjugates. Those are your sort of 3 options if you get 0 over 0. And the nice thing is, it's pretty easy to tell right away which of the options you should be taking. Let's first make sure we get 0 over 0. So 3/5 minus 3/5 over 1 minus 1. Yep, that's 0 over 0. So let's get out our, I've heard a math teacher call it their fraction blaster, to blast away all those denominators. So on that first one, let's see, the 5's cancel, and I'm left with 3 times x plus 4. On the second one, the x plus 4's cancel, and I'm left with 2 plus x times 5. I do have a minus sign in there, so I better be careful about that. On the bottom, we don't really want to multiply it out because we're hoping something will cancel. So let's see, 3x plus 12 minus 10 minus 5x. I'm just going to stay with the top here for a minute. So that's negative 2x plus 2. Okay, that's good, but not good enough, right? Like,
couldn't you just cancel x plus 4?
You don't want to cancel these x plus 4s, I hope. Because this one's eligible to be canceled. This one is not eligible to be canceled because it's not a factor. There's other stuff being added and subtracted. We get here and nothing cancels. What could we do? Yeah, if we factor out that negative 2, that leaves an x minus 1, which is great because that's what we want to go away. And then we get lazy. I guess officially we're supposed to keep writing a limit all the way down the page. But we'll just throw it on here at the end. So negative 2 over 5 times 1 plus 4 is 5. So negative 2/25. 44, skip 45. That takes us to 46. Okay, this is landed perfectly because we get to see one of each of the algebra tricks. We did the factoring already, then we did fractions. Now we've got a conjugate. I suppose I should make sure that this is, 0 over 0. So let's multiply by the conjugate. And remember, you multiply out the conjugate stuff. That's the point of multiplying by the conjugate. But don't multiply out the other stuff. So, because 1, it would be ugly, and 2, because hopefully something cancels. So in the top, x squared. The O and the I of FOIL cancel out, so I'm not writing that down. Write it down if you want to, but then it's going to go away. Minus 6 plus x over x minus 3, x plus square root 6 plus x. Whoops, I need parentheses on that. Nothing cancels yet. but I think I can factor the top, x minus 3, x plus 2. And now that x minus 3 will cancel. And then we get to try again with substitution. So 3 plus 2 is 5 over 3 plus square root of 9. So 5/6. So I guess that had a little of both. We had to conjugate, but then we also had to factor. Right, and down the middle of the page here. Okay, if I plug in 2, that's my first go, I get negative 3 over 0. So that's going to be one of the infinities, so already I can throw out some of this stuff. Now it's a matter of which infinity is it. 2 minus 5, negative 3. In the bottom, I've got to be more careful. 2 minus a little less than 2. So 2 minus a little less than 2. So that's 0, but which side of 0 is it? It's the plus side of 0. Right? Because a little less than 2 would be like 1.9. So yeah, that would be plus. So negative 3 divided by a positive 0. I shouldn't say that. That's not exactly right, but that's what our brain is thinking. We're headed to infinity, but because of that negative, it'll be negative at infinity. So those are those tricky ones where it's still just substitution, but you got to be real careful about like which side of 0 you're on. 52. As x goes to infinity, this is the shortcut rule. Let me do it the long way, and then we'll do the shortcut. So as x goes to infinity, what matters most is the big powers. So 4x cubed, and then in the bottom 9x to the 5th. So that's 4 over 9x squared. And as x gets really, really big, 4 divided by 9 times infinity squared, and that's headed to 0. The shortcut is top no, bottom O, equal co. And since the bottom degree is bigger than the top degree, degree 3 compared to degree 5, this is a bottom O problem.
So did we even have to like plug in infinity? We could have just seen that the bottom was bigger instead of...
Yes, if you want to use this shortcut, I'm okay with that. But please only use that shortcut as x goes to infinity. Right? Don't. Again, some people, top no, bottom O, equal co, they just use it for everything. You're like, wait a minute. Only as x goes to infinity are you allowed to use that. 55. X goes to pi. Oh, this one might work out. Tangent of pi is, let's see, sine over cosine. Sine of pi is 0, so that's 0. Sine of 0 is 0. Wait, sine of pi is 0. I got the right answer the wrong way. Sine of pi is 0. Cosine of pi is negative 1, although it kind of turned out it didn't really matter. 0 minus 0 over negative 3, that's just 0. So that one, that's why we substitute first. I was worried I was going to have to be some kind of factoring or trig or conjugate, I don't know, but it turned out none of that was necessary. 758. Using all my math skills to just keep up with which problem I'm working. 58. For what value of x does f have a discontinuity? Okay, So I'm not worried about like the types of discontinuity. If it just says discontinuity, things in the bottom, things that make the bottom 0 are going to be discontinuous. So I don't even have to factor the top. Like those are my values that have a discontinuity. Now, so full stop. That's the end of the problem. It could have asked more, right? The x's cancel, so that means there's a hole at 0. X minus 4's cancel, so that means there's a hole at x equals 4. X plus 7 is still stuck there, so that's a vertical asymptote. But it did not ask for those, so I did not need to do that. All I had to do was look at the denominators. Skip 59, skip 60, 61. The graph of a piecewise function is shown. Which of the following statements is true? That graph, is that the same graph that was... I feel like we saw that graph earlier. G has an infinite discontinuity at -7. Yes. Because infinite discontinuity, fancy word for vertical asymptote. Statement 2. G has a non-removable discontinuity. So that means vertical asymptote or jump at x equals -1. But -1's a hole. That's removable. That's fixable. So statement 2 is out. Statement 3, removable discontinuity, that's a hole at -6. That is not a hole at -6, that's a jump. So statement 3 is not true. So only statement 1. So those are kind of those vocabulary questions of, can you tie some new words to concepts you already know? All right, lastly, prove, oh that sounds fancy, that g of x has a discontinuity at x equals 7. Okay, well let's back all the way up to the definition of continuity, and maybe we'll start with that. That was the limit from the left equals the limit from the right equals the function value. So let's try to plug into that, and if something breaks down, then it won't be continuous. So from the left, well, that would be using this one. So let's see, x plus 7, x minus 7 over x minus 7. So this x minus 7's cancel. 7 plus 7 is 14. From the right, well, we'd still be using this one because we'd be at like 7.01 and 7.001 and 7.00001. So we plug in 7, obviously we're going to get the same thing. Also 14. And then lastly, f of x, so f of 7, I guess I should have made more, f of 7, we'll use this guy. 2 times 7 minus 1 is 13. So close, and yet not really. So g is discontinuous at x equals 7. So the proof, again, not a geometry proof at all, really is just start with the definition of continuity, and either it works or it doesn't. So with the proof stuff, same thing with 63. Use this definition as your starting point, and then if it all works, then you're good. If it doesn't work, then it's discontinuous.
I'm confused why you use the top equations for both.
Because the top equation is only when x, or is for when x is not 7. So if x is 6.9 or 6.99 or 6.99, I'm still on this branch. So what's going on here is there's a hole there, and this spot down here did not fill the hole. The hole's at 14, but the dot is at 13. So that one is discontinuous. But the picture doesn't prove it. The mathy definition is what proves it. Okay, so stay tuned for more videos for all the other answers. Yeah, press like and subscribe, for sure. Comment down below with your favorite problem.